So I'm going to show you in this video how to convert a NiCd powered cordless drill like this Craftsman I've had over here for several years. The NiCd batteries inside are like really losing their charge. It barely has any runtime, and new batteries cost like 30 or 40 bucks. A new drill set costs about 70 bucks. I figured for much less than that I could replace the batteries inside with some modern LiPo technology. When I first tried this out, I bought some of these what they call 18650 lithium-ion cells, and I put 4 of them in a series, hooked them to the drill, and although the drill did run, it actually wouldn't run at full speed, and that's because I bought the wrong kind. These lithium-ion batteries come with or without protection circuitry, and the ones that I bought actually have the protection circuitry, and that is used to prevent overcharge or over discharge on these cells. Without that protection circuitry, these cells, you can kill them if you over discharge them or overcharge them. But the bad thing with that circuitry is that it prevents the drill from drawing the amount of current it needs, and ends up just cutting out. So if I were to do this again, I could buy 4 of these types of 18650 cells, which actually have higher milliamps in about the same size as what one of these lithium polymer cells would take. I picked this up from Hobby King. It's a 1.6 milliamp for about like $8 or $9. It has a pretty high discharge rate of 20 to 30 C. Comes nice and small, but again, you could run either this type of cell or this type of battery technology or lithium-ion technology, but without the circuitry that this one here has. It does say over here, I'm not sure if you can see it, but it does say PCB. It's like a protection circuit board, I believe. In any case, either ones will work fine. The key to running lithium-ion batteries with no protection circuitry or lithium polymers, that you've got to have a way of keeping an eye on how much current or how many milliamps left the battery has. So I picked up this little battery monitor that you can set how low you want the batteries to be before it starts to give you an alert. This is like a couple of bucks from eBay. Works really well. I bought a switch from a local supply store so I can turn that on and off even though the battery is inside the case. I bought some connectors from Hobby King to run with these cells, and some balance plugs also from eBay. These are 4S balance plugs, male and female. The idea is to put this battery inside this case with a monitor and a switch to turn the monitor on and off, and a balance plug hooked up to the balance connector on the battery, so when you charge the battery you can charge the cells individually. By the way, this is a 4S pack, meaning there are 4, it's a 4-cell LiPo battery, totaling 16.6 volts when it's fully charged. It's a little higher than the 14.4 that the NiCads were at, but I tested it, it runs just fine, and being 1.6 milliamps will have slightly longer runtime than the original NiCads that are inside the pack now. So first thing we'll do is open up the pack, which takes a bunch of security Torx bits, and let me basically pop this off. You've got 5 screws around the case. We'll take those off and then see what's inside. So I've got all the screws removed from the battery pack, and when you take the top cover off, you'll see it's pretty much, you know, a bunch of NiCd batteries in here with this connector. You basically just pop this out from the case, and these are your NiCd cells, all wired in series, and they're not bad when they're new, but you know, I think this is like about 6 or 7 years old. They've seen better days, and it's time to replace them. So what you're going to want to do is take this piece off from this topmost cell. It's held in place by little of tack welds on the top of the battery there. You'll just break it off and save that. All we're going to use are the connections for these two posts. The side posts won't be needed. This is your positive and negative. So looking on top of the battery here, you got your positive and negative. These two won't be used. So I've done some work to the case and basically got it ready for the LiPo pack. I drilled a small hole in the side and put this little switch on, and again this switch is going to be used to turn on and off the battery alarm or battery meter. And on the other side I made another hole for the battery meter, which is mounted inside the case, and I'll show you that in a minute. On the back I made a small hole for the 4S balance plug. As you guys know, LiPo batteries come with a main lead and the balance lead, and this lead is used to balance charge the cells so they all charge up to the same capacity. Really important with LiPo packs that you always balance charge them. As you've seen, I mentioned earlier that the top connector over here, you only need to really have the positive and negative. I ended up breaking off this one, you know, when I was rough housing it, taking it off on this pack, so it's gone. But again, you only need to really have these two. You can leave this one in place or leave the two top ones, the top and bottom in place. It doesn't matter as long as they're not connected. The key is to save the positive and negative, which you'll see over here. When I open the case, you'll see I've done a bunch of wiring in here. And I'll explain what I did. The positive and negative, I ran some wires down the center of the post to this XT connector, this female connector. This will plug into the battery's main connection to give the drill its, you know, full capacity through these nice thick wires, thick gauge wires. So the balance plug you see over here is pretty much like a splitter. It's like a Y connector that I ended up making. And the purpose of that was this. The balance plug in the battery, if I hooked it up straight to the meter, I wouldn't be able to charge the pack without taking off the battery from the case and unplugging it from the meter. If I left the battery 4S connector hooked up to the back, I wouldn't be able to hook up the meter. So basically I created a Y splitter, or Y adapter rather, that looks like this. I've got a female 4S balance plug glue gunned in place to the case over here with some wire that hooks up to another female connector. And then on each solder point, I hooked up another set of wires that I soldered straight onto the leads of the battery meter. As you know, these batteries, you can run these like small little voltmeters on them that when you plug in, it cycles through and gives you voltage readings for each cell, and then tops off the last reading with all cells. So this is a basic reader that just reads. I wanted to have an alarm. That way if any of the cells went below a certain voltage, I'd hear it and I'd stop using the drill and switch battery packs. This one costs about $2 from eBay. And it's a small little button that you can push up over here that you can set the alarm voltage to be whatever you want. So let's say I usually don't like running my cells below 3.76 volts, but it goes in increments of 0.10, so I have this meter set to go off or send me have the alarm go off if any cell goes below 3.8 volts, and it's quite loud. So when you plug it in, I believe this is positive. It's quite loud. It'll go through all the different cells, similar to the other one, but again, if you set the meter up over here to a different voltage, then if any of the cells go below that voltage, the alarms go off, and that's the time to stop. So just to show you how that works, I'll press the setting here until we get to 3.8. So that's off, meaning it's not gonna go off at all. This is 2.7 volts, 8, 9, 3, 1, 2, 3, 4, 5, 6, 7, 8. So that right now is set for 3.8 volts. So if any of the cells right now, which are 4.11, 4.10, if any of those cells go below 3.8 volts, this will set off the alarm and I'll stop using the drill. But of course, if I had plugged this directly into this Y harness over here, this would be on all the time and would eventually drain my battery. So if you can see these little green wires running down over here, what I did was on the very last wire, which is this brown one here, it's on the battery, it'd be the black one. This is your negative. I basically, on the harness plug, cut this wire and ran it to a switch. That way I can control the meter when it's in the case, and only turn it on when I'm actually about to use the drill. And what I'll do is I'll hook up the battery to the connector and this to the main plug. So now essentially my battery is hooked up to the drill. It fits nicely in the case. I'll show you that up, when I have two hands to work with. And before I use the drill, I turn the switch on and my pack's ready to go. Hook this up to the drill over here. Sorry, I moved the camera. So plug the drill onto the case, and got a LiPo powered drill that used to run on NiCd batteries. So with that said, I'll put the battery in the case and show you how that all fits in nice and snug. So here I've got the battery in the case placed nice and snug. I actually ended up bending the pins of the switch, as you can see right over there, just to give it more room. I trimmed off a piece of plastic from this post over here so the battery could fit nice and snug over here. I glue gunned the alarm in place, and I've got the charging plug, or the balance plug hooked up, and we'll just tuck that in nice. And there's actually a ton of room in this case, since the LiPo pack is much smaller than all of the NiCd packs that were in here. Just make sure nothing gets pinched when you put things back. And that's it. LiPo powered pack converted from a NiCd pack. You can put the same set of screws back on. I ended up picking up a pack of 4x34 Phillips screws to replace the Torx bit heads, and that's pretty much it. When you're ready to charge this pack, I have one of these RC battery chargers that I use for my my RC toys. Got a bunch of connectors over here, and as you can see, it's got a balance plug here for balance charging different cells. 2S, 3S, 4S, 5S, 6S, and it comes with the X60 connector. So when I'm ready to charge my pack over here, I'm going to use the positive and negative alligator clips that I would just hook up individually. Again, this is negative, that's positive. And then the balance plug, I made one by connecting two 4S male plugs to itself. One end would go into the slot I made over here, and the other end goes into the charger's balance plug, just like that. So, and you can go about charging the LiPo pack inside the case without having to take anything apart or disconnect anything. And you can even, keep an eye on the cells as it's charging by leaving the battery monitor on. And while it's charging, I should see that, those values go up. And that's about it. Hope you enjoyed the video, and save those drills that you guys have. They're great drills, just need some new battery technology. And again, you can do the exact same thing that I did with the LiPo pack with the right lithium-ion cells. And basically everything else would be the same. You'd use the same balance plugs. You'd hook up a balance lead to the cells wired in series with one of the leads for each positive on each cell, and then the negative would be a common lead, and replace your NiCads with either lithium ions or LiPos, and for a lot less than what you'd pay for a new pack if you were to buy brand new NiCad packs for your older drills. That's about it. Hope you enjoy it.